Hey guys, it's Miss Miklos, and in this lecture we're talking about problem solving. And in fact, we are going to go through a lot of the little steps and just making sure that we really know how to problem solve versus just knowing how to solve a word problem. And my guess is the two examples we're going through are both going to be things that you guys can really solve without doing all these steps. However, at a point, we will get to some problems that are much tougher, so these basic skills are going to be very important. So looking at number 1, a bag of lawn fertilizer claims that it will cover 5,000 square feet of grass. If your yard is 27,500 square feet, how many bags of fertilizer will you need? Often, a really good thing to do is to go through and highlight or underline the things that we think are going to be important. And in fact, I think this 5,000 square feet is going to be important, the 27,500, and how many bags, because that's what we're really trying to find. After that, I'm going to write a verbal model to tell us exactly what we need. And in our verbal model, the phrases we use don't need to be exact. This is just going to be an example of something we could go ahead and write. The way I'm writing mine, I'm going to say that the yard size is going to be equal to the number of bags of fertilizer times the coverage per bag. Once we go ahead and figure that out, now I can substitute in the things that we know. For example, we know that the yard size is 27,500 square feet. And even though it's square feet, in my equation I'm not going to write that label, but when we answer our question, I will write whatever label is appropriate. Equal to the number of bags. I don't know the number of bags, so we can use any variable that we want to use. I'm going to use X times the coverage per bag. It tells us that it covers 5,000 square feet per bag. So I'm going to write this as 5,000x. Just a reminder, whenever I'm writing multiplication, when we have a variable, I'm always going to write the coefficient first. We never say things like x 5,000, okay? It is 5,000x. Now this becomes a simple problem that we've already learned how to solve. So to get x by itself, I'm going to divide both sides by 5,000. And I get 5.5 equals x. So that would be the algebraic answer. However, I need to remember to answer the question. If I walk into Home Depot or wherever I'm buying my fertilizer from, and I say I want 5.5 bags, they're going to laugh at me because I can't buy half of a bag. So my answer here is going to be 6 bags. So this is just a simple reminder that when we have a word problem, we are answering a question. I'm not just solving an equation. Our second example, you and a friend shared the driving on a 300-mile trip. And I'm going to underline that because I'm guessing that sounds important. Your friend drives for 3 hours at 52 miles per hour. How fast must you drive for the remainder of the trip if you want to reach your hotel in 3 more hours? This problem is a little bit more difficult, and we really need to rely on our previous information that you've just learned throughout your course of math. In fact, it looks here like we're talking about a distance, time, and a rate. So some of you may remember that we have a formula for that. Distance is equal to rate times time. Now what makes this one a little bit more complicated than just that is we actually have 2 different distances. We have the distance your friend is driving and the distance that you are driving. So my verbal model is going to look like this. The total distance is equal to your friend's speed times the hours that they have driven, plus your speed times the hours that you drive or have driven. So let's go ahead and substitute in the information that we know. We know that the total distance is 300 miles. Your friend drove at 52 miles per hour for 3 hours. And a quick note that I just want to point out, since it is talking about the rate in terms of hours, my time also needs to be in terms of hours. So if it was in terms of minutes, I would need to convert it into hours. Plus, your speed, that's what we don't know, that's what we're trying to find out, times the hours driven. It's telling us that we want to make it in 3 more hours, so I'm going to write that as 3x. Now when I'm solving this, 52 times 3 is 156. In order to get x all by itself, I'm going to subtract 156 from both sides. So I get 144 equals 3x. I'm going to divide both sides by 3. And I get x equals 48. Now I know that is not my final answer. We need to answer the question, which is how fast must we drive? And that would be 48 miles per hour.